Now for this video, we're going to start diving into some of the batching options and iteration options. So the first thing we're going to do is look at the workflow that we've already developed and use it for a large number of samples rather than just one sample. So if we go back and let's create this. Let's get on here. Save. QC for mapping, we're saved. If we say run, and now if we go into reads, I've imported some additional reads into this reads folder here. If we grab all the reads, we push them over, and we can click batch over here. So what this will do is it'll run that workflow individually for all, I think there's about 12 of these specimens in here. So we go through next, it's going to look similar. We're going to use the organization of the input data. It's showing you the batch overview, all the different analyses it's going to run. Click next. It's asking us for the genome, primers, this is all pre-populated, and then we're going to save into a specified location. So here, let's say in the tutorial, results, let's add a new folder, first batch test. Okay. And finish. Now this is going to take quite a while, so I'm going to pause the video here and come back when it's finished, probably about another 10 minutes. So the workflow is finished now in batch mode, and let's take a look at the results. So go to first batch test, and you can see everything is broken down into the directory structure that we designated in the workflow. One of the things we have are these track lists for the individual specimens that we put to the workflow. So the 62 one here is the one that we've normally been looking for, and you could see and here's the variance, the mapping, and the primer track. And for each specimen, you can go in and look at how these results are for each individual specimen, whether it passes, fails. But wouldn't it be nice to create a workflow where instead of having to go in and look at each one of these individually, sit here and open up one after another and look at the results, wouldn't it be nice to look at, an entire run and all the variance on one view, all the coverage graphs on one view, etc. And that's what we're going to talk about now. So the modules we're going to introduce are the iterate and the collect and distribute. So let's go back to our workflow here. And so this is a different way of batching rather than hitting that batching is this iterate and collect and distribute. I think the best way to demonstrate it or for you to understand it is just to watch how it works and how I change our workflow. So the first thing I'm going to do is look for a function called iterate. Okay. And we're going to add this in. Here's an iterate. And we're going to insert this right after the paired Illumina reads. So instead of this feeding straight into the trim, we're going to remove that. We're going to feed into the inputs. We're going to remove this one. And for the output here, we're going to connect this to these two different ones. So you can see we've just inserted in this iterate step here. Everything else down here will keep the same. I'm just going to drag this down to give a little bit of room, but we're going to add a special module over here also called collect and distribute. So say add element, and it's under, once again, the control flow. So let's add that. Collect and distribute. And this is how we're going to make our kind of composite view. So in that composite view, let's say we want to have our genome and our primers like before, but say now we'll forget about the mapping. We'll just look at the mapping graph for convenience, and we'll look at the variance. So what we have to do is collect the variance tracks. We have to collect the graphing map tracks, and then we have to create a new track list and also bring in our primers and our genome. So we'll get another create track list here also. bring that into the picture. And we need another collect and distribute. Okay, so we have this one track list which we used for our track list output for the composite of all the tracks for an individual specimen. This track list over here is going to be a track list for all the specimens in our run. And this is a great way of QCing, say, a run of 48 specimens or something like that. We're going to bring our primers in there. We're going to bring our genome into this track list. But then what we're going to do is we're going to collect and distribute our variant tracks from the different specimens, and we're going to collect and distribute our graphing track from the different specimens, and both of these we're going to feed into our new track list. And the configuration here, there really isn't any that's important at this point. And what we want to do here is use as a workflow output a new track list, and we will designate this as, let's see, we will say composite, and I don't know what it'll do for the input, but let's see, input, and let's call it master track. Okay, let's finish that. And let's rename this. So we want to file, save as this workflow. We're going to save it into our workflow folder, 13, and we'll call this batching. Okay. Now, let's run this one more time with all those specimens and see what happens. So run, and we're going to go up to our reads here. We're going to select all the reads, but we're carefully not going to select batch. Let's hit next to use imported organization input, and see how the behavior is the same here because we have that iterate step in there, but you could see the batch overview. Same primers, same reference, and then here we'll call this second batch. Okay, we'll let this run and be back in just a few seconds for you, about 10-15 minutes for me. Okay, that analysis is finished now, and let's take a look at the results from having the iterate and collect and distribute modules in there and compare it to when we ran the batch the first time. So let's create a little room here. So here's our first batch, and here's our second batch, and you can see that they look pretty much the same. You know, we have the track list here from our first run. We still have the track list here for the second batch, and you could see those individual analyses that we set up originally. But now we have this new folder called composite, this new directory composite. And if we look in here, see it's created one large file. And if we look at the results, we have our genome, we have our primers, but then we have the whole list of all the variants from all the specimens that we ran through this analysis. In addition, we have all the graphing maps from all the different specimens. So this is the tool that you really want to use when you want to, first, if you have SARS-CoV-2 sequencing runs on your Illumina and you want to QC and look through your whole list of specimens that are going through to see which ones passed and which one failed, you could use this type of view and go in. You can go in and look at the variants that are shared, and it's the way that we're building things now. We're going to use these types of iterate and collect and distribute to also collect our consensus sequences for data sharing. We'll use it to select sequences and feed them into phylogenetic analysis, and lots of other actually really neat tools for SARS-CoV-2 sequencing. So we'll stop right here, and the next time what we're going to do is we're going to come in and I'm going to show you how to use the collect and distribute to collect your consensus sequences into one file, and then it may take more than one video, but bring in a workflow to then filter those consensus sequences for those that could be shared with GISAID or GenBank, etc. Thanks a lot.